One of the underpinning questions in Project 2.5 is how do we deliver a near natural flow regime in the urban context?
So at present, we've got strong evidence that waterways are inevitably degraded with small level of urbanization. So just about 2% of the catchment where impervious surface are connected to the drainage system onto the river is enough to degrade waterways. And actually degradation starts with the lowest level of impervious surface connected that we can measure. We've also got reasonable evidence that by maintaining a natural water cycle in the catchment, we can in fact protect waterway condition. So I guess that's what this research is aiming to resolve. What could we do in the catchment? What does it, how does it change the hydrology, and ultimately how does that affect the resulting condition of the stream?
So for this project, we're working at a range of scales. We're studying individual systems such as infiltration systems, stormwater harvesting systems, to see how well they work. So for example, one of our PhD students, Jeremy Bonneau, is looking at the fate of infiltrated water. When we have an infiltration system or a rain garden, where does that infiltrated water go? Does it end up in the stream, or does it get intercepted and caught by sewers or caught by other urban infrastructure? We're also working at that larger scale of trying to see, well, when we lump up a whole lot of these, what we call stormwater control measures at a catchment scale, what's the effect on the flow regime? And we're working in both Little Stringybuck Creek and Dobson's Creek, where these kind of interventions have been put in place at quite a serious scale to see what effect do we have on the stream flow. So the outcomes of this project to date have been pretty interesting. At that individual site scale, we've seen that stormwater harvesting systems do work quite well, and we've been almost surprised by the level of flood mitigation we've been able to deliver at a subcatchment scale by implementing these things. But we've also shown the importance of maintenance, that if these distributed harvesting systems don't have a good maintenance framework, then their performance is at risk. Our investigation of infiltration systems has been interesting because we show that that path of water from infiltration through to the stream is far from simple. There's many places where that water can get trapped, caught by a sewer or something like that, and so that's got some important implications for where we put these systems. At the larger catchment scale, we've been particularly looking at the effect of a range of stormwater control measures on the flow regime in the Little Stringybuck Creek, and we're seeing a significant impact, but smaller than we would have expected, and we're really trying to understand why that is at the moment and understand the effect of other factors such as climate variability.